Okay, on the previous video, we have a look at an example 4, where the limit, the limits given, but not the order of integration, and also the limit on the double integral, but you can obtain that from the given information here. And also the region is because they are all constant, so the regions is we have a rectangular region. Okay, so now we want to look at more something more complicated, which means that our region is no longer a rectangular region, which means that part of the limit, the limit of integration is no longer at least one of the, we got 4, right? And then at least one of the limit here, it is a function in terms of x or in terms of y. It depends on the integrand and the order of integration that we have. Okay, as long as you can see that on the limit here, it is a lower bound or the upper bound, there is function and expression, so we know that the region is no longer a rectangular region. Okay, so what example of the non-rectangular region? So for example, you have a triangle where you can see that the region is bounded by the y-axis and x-axis, and also this line. Okay, this line is not y equal to 1, it's not x equal to 1, but it is something y equal to minus x, maybe. Okay, or maybe y equal to 1 minus x, and you know the limit. When there is a function, so the limit should be not a constant. Okay, and also the combination, so the region is bounded by the y equal to x squared and x equal to y squared, and you can see this particular shape. And also you have this one, so it is a region bounded by the y-axis and the line of y equal to 1, and also the curve of y equal to x squared, and you have this particular shape. So as I mentioned before, about the sketching, you need the sketching a lot in this chapter, because you have to draw, you have to sketch the region, what is the regions looks like. And after that, for triple integral, or finding the volume, you have to know what kind of solid that you have. And I'm talking solid is something that you can touch. For example, okay, I have a mouse here, so this is called solid. You can touch it, and it is a surface, right? Closed and bounded surface. Okay, and similarly, I have the pencil, the Apple pencil here. So it is a solid because I can touch it, and also it is a closed and bounded surface. Okay, but this one is not a solid. Okay, this is a paper. So this is not a solid. Even just assume that I have one piece of paper, very thin. Okay, very thin. Just assume this is very thin. I have one piece of paper. So this is open surface. So this is not solid. But if you have something, let's say a box. Okay, rectangular box. So you mean that the box is a solid because we can touch it, and the box is actually bounded by some surfaces. You got 6 surfaces, right? So that is called solid. Okay, so in this chapter, you have to sketch the region, which is on 2D, what you can see here. So this is region on 2D. When I'm talking region, then the sketching is the closed and bounded curve on 2D. Whether on y-x plane or x-z plane or y-z plane, depends on the situation or the problem that you have. Okay, so, and also you have to sketch the solid. So that's why I told you before, the sketching of the surface in chapter 1 is very important here. Okay. Okay, so about the integration, the double integral of if you have the non-rectangular region. So how can you determine the, okay, let's say now you have double integral, and you have the function, the integral in terms of x and y, and you have dA in general. over the region, and your region is should be on XY plane. So I just put this to notify ourselves that the region is the closed and bounded curve that you can see on the XY plane. Okay, now we want to talk about how can we determine the limit, the dx dy, whether you have to use dx dy or whether you have to use dy dx. And how about how can you determine the limit here? Because now your region is, maybe you have a triangle. Okay, you have a triangle, and that is your region. Okay, on y-x plane. So last time, all the limit of x and y, they are all constant, so that's why you will get rectangle. So just easy, because you just determine which order of integration that you want to use, but that one still based on the integral that you have. If it is easy for you to integrate first with respect to x, then we proceed with the dx dy. But if you can see that the integral here is more easier to be integrated with respect to y first, so you have to use dy dx. But about the determine the limit is not so difficult. Okay, because if you want to change whether dx dy or dy dx, you can just swap the location of the limit over here, but not for non-rectangular region. Okay, so firstly, the step is, okay, whether you have to determine the limit first and after that the order, or you have to determine the order first and after that the limit. So actually, the first step is you have to determine the order first. Okay, you have to decide you want to use dx dy, which means that x first, or you want to integrate y first. So after you decided, when you decided, then you have to find the limit. So that is the step. So you cannot do the, finding the limit first and then after that you decide about the order. So that is wrong. The step is you have to determine or decide which order that you want to use, then after that you have to determine the limit. Okay, so how can you determine the limit? So it depends exactly, of course, from the region that you sketch. So if your sketching is wrong, then your limit is also wrong, and then you cannot obtain the correct answer. So meaning that the sketching is very, very important. The starting process there, the first step, this is the very critical step, the first step that you have to obtain. Okay. So now, before I, okay, I want to explain this one, but I don't want to explain using this one word by word, okay, because I don't like it. This is too wordy. Okay, so now, so what is actually in type 1, type 2, why we give name? Actually, that you don't need to bothering the name with type 1 or type 2, but because of this, we want to make sure that the process of your understanding is follow the sequence. So that's why we put the name, but actually you don't need to know what is type 1, what is type 2, because we never ask you this, just to differentiate, just to separate the process. Okay, so now what is the type 1 means? Okay, so so the type 1 means, now we are talking about the limit, okay, the limit itself. So so for type 1 means that, okay, now what can you see here? Okay, so maybe I have to put the slide on here, just a second. Okay, so what does this mean, all these things? Okay, this one is actually want to tell you that okay, you have a double integral. Okay, you have a double integral of the given integrand. In general, we have dA over the region R. Okay, now what is the region looks like. So you must have the information provided. So if there is no information provided, then you can claim that the question is incomplete, then you cannot solve. Okay, so okay, based on the information provided, so you can see that it stated that x is the limit of x is from a to b, which is constant. Okay, we have x constant, and then the limit of y is a function. So in general, we put g1, g2. So g1 lower bound, g2 the upper bound. Okay, so in this case, g1, g2 is the function of x. You cannot have the function of z. Z is out of the scope here, because we are talking about two variable function. The input variable is just x and y. We don't have z. Okay, because z is the output. Now we are talking about the input variable. Okay, so now for type 1, we want to focus on the region where the x constant and the y is function. Okay, so the y function means it can be both of them are functions or just one of them. Remember, I told you, if you can see at least on the limit there is one function, so meaning that your region is no longer a rectangular region. So it can be both functions or just one of them. Okay, but for if you say that, okay, if there is x constant, meaning that okay, so that just a second. Okay, so that is the first one, type 1, type 2, and type 2 means that now x is a function. Just a second. Okay, now x is a function. So now x is a function, h1, h2, and y is a constant, c1, c and d function. Okay, so that is type 2. Okay, so now based on this understanding, so we say that, okay, type 1, x constant, y function, type 2, y constant, x function. So now how can we determine the limit? Okay, okay, about the type 1. Type 1 says that x constant, right? X constant. So you have to bear in mind, keep in mind, okay, we have something that x constant, the limit of the x constant, but y can be constant and can be function. Okay, but x must be constant. So okay, let's say I choose this one. Okay, so this is your region. So this is your region. Okay, so now again, double integral f x y. Okay, so yeah, now type 1 means that x constant. So for non-rectangular region, the limit, the variable where the limits are all constant, you must put as outside the outside integral. Okay, remember this one is called inside. You do this first, but this is outside. You have to make sure that the outside integral must have a constant limit. Okay, so meaning that in this case you have to put the x outside, which means that the x is outside. So x is from a to b. So since you choose that the x outside, so the inside should be the y, and this one is the limit of y from g1 to g2. Okay, so just now I said that you have to decide the order first. Okay, dy dx or the dx dy. So in this case, you can, if you look at here, if you have x constant, so you have the dy dx, right? Because we want to make sure that the dx should be outside the integral. Okay, why we should put the constant one should be outside? Because we want to make sure that our final solution, it will be a value. Okay, it should be a value. That is because of the concept of definite integral. Whether you have single integral or double integral or triple integral, is So you have to make sure that your final answer should be a value, because the concept is when we have defined integral, we must have a constant, right? So in order to make sure that we follow that concept, so we have to put the limit where there are all constants should be outside the second one, okay, which is the outside I would say this one is the inner integral, this is the outer integral, which is outside. Okay, that is just my own terms. Okay, this is inner integral, this is the outer integral, just my own term. You can't see that when you read the book. Okay, so meaning that, okay, back to the order of integration. So if you have x constant, so you have to put the x outside as outer integral. We have dy dx, which means that y function x constant. Again, y function x constant. Y function x constant. Okay, so that is the thing that you have to know. Okay, x constant you have to put outside. Okay, using the similar ideology, so we implement this for type 2. So for type 2 says that now y is function. Okay, now back to the double integral over the region, and you are given the integral. Okay, so now we said that for this particular case, your y is constant c to d. Okay, and then x is a function. Just now they use h. Okay, h1, h2, h1, h2. So since y constant, so you have to put dy outside, and then the limit of y also constant c to d. So since you already you have chosen the dy as outer integral, then the inner integral should be related to dx. So now you put the limit of x. The limit of x is a function h1 to h2. Okay, so it's not necessarily the function should be both. Okay, for inner integral, doesn't matter if you have only one of them function or both are function. But for the outer integral, you have to make sure that the limit they are all constant. Why? Because we want to make sure that your final solution should be a value, a number. Okay, that is from the concept of definite integral. Okay, so you don't need to worry type 1, type 2. So we never ask you what is the name of this particular case. No, we never ask you that. But we are very particular on how you solve for the double integral if you have non-rectangular region. We never ask you the name, so don't worry. So now, by now you have to think that for non-rectangular region, there are two possibilities of cases that you have to face through, which you have x constant or you have y constant. What I'm saying, x constant, y constant, both the lower bound of and the upper bound of x should be constant. Similarly, if you say that y constant, the lower bound of y and the upper bound of y they are constant. Okay, so back to the main x constant. So how can you determine the limit? So now let's say you have done you have decided to choose this particular order of integration. So you have decided that I want x to be constant. Okay, but why you want to use the x constant? So I will explain that when we come to the example. Okay, so now just focus, how can you determine? Okay, so now based on this, so this is origin. So based on this example, so when you want to determine the limit of y and x for x constant, you have to put a line. A line is just your you just create that line. You can see that line here, right? You have this one vertical line and also vertical line over here, isn't it? Okay, now you just create yourself. Actually, in the question, there is no line, just a region here. So the line, the vertical or the horizontal, you can see for the second slide, you can see the horizontal line. So there is a reason why we have to put that. It just why? Because that line will guide you to determine who is the lower bound, or what is the lower bound and what is the upper bound of x or y. Okay, so now let's say you decided to choose the x constant. So and normally in the standard orientation you have y and x here, right? So sometimes you can, sometimes we need to change, but in this case I want to explain in more general way. So let's say your orientation of your plane, this is y and this is x. Okay, so in this case, if you say that I have x constant, the limit of x are constant, so you must draw this vertical line. So this vertical line. Okay, now you can see from this region that you shaded, so you must shade the region so that you know the boundary of your region. Okay, so from this region, from this region and also from the line that you create, the vertical line that you create, so this line is lying between which boundary and to which boundary. I would say that just thinking of x is constant. So now you can see that this is the boundary, I would say the smallest value of x that possible, isn't it? And this one is the highest value of x. So we are thinking about value only, because we said just now x constant. It can be x equal to 1, x equal to 0, x minus 1. So don't think about the equation, just thinking about the value of the x. So now you said that the lower bound is coming from this line. So what is the equation of line? X equal to something and should be a constant. So you can see here this boundary or this line is belongs to x equal to a. So you can see that that is becomes your boundary, this one, right? And that line is actually belongs to x equal to a. Okay, and then you look at for the highest, the possible what I'm trying to say, the possible maximum value of x. So you can see that the maximum value of x is coming from this line. So what is the equation of this line, this straight line? So this one should be x equal to b. You can see this line, right? Should be a straight line, because you said that we want to set x constant. So now you can see that x is lying from a to b. Okay, so then you got the limit of x. Now how about to get the limit of y? Okay, using this line again. So this is very important. So the vertical line that you create, that you sketch, is just to guide you what is your lower bound of y and what is your lower bound of the upper bound of y. So you can see that it's just like you walk. Okay, you're walking. So you're walking from the smallest value of y to the highest value of y. So if you are thinking that you move from the lower bound, I mean, when I said that lower bound, upper bound, so the value of the lower bound should be smaller than the value of the upper bound, right? Meaning that if you are thinking about y, so the value that you have to fill in here should be smaller than the value of that you fill in over here, isn't it? So now it's just like you are moving, assuming that you are you're just walking, okay, on that direction, okay, along the y-axis. So just assume that now you are moving and you're passing through the region. You're walking and you're passing through the region. So you are here now. Okay, you are over there, and then you want to pass through this area. Okay, so using this one, okay, I just using this line. So if you are walking forward, okay, which means that y becomes increasing. So what is this, the first point that you can see, which touch on the region. So you can see this point at the first, right? The first point that you can see. Okay, so that point is, okay, now we are thinking that y cannot be constant. If you say that y constant, then you will have the rectangular region. Now you have to think that y is a function. So now ask yourself, okay, this is the first point on the region that I met. Okay, you met this one, this number, this point. So this point belongs to which function? So you can see this curve, right? So this curve is given by g1. So then you can see that the first function that I met is g1, which is you met this point, and this point belongs to g1. Okay, and then you move along, just walking along this line along the region where y is keep increasing. So what is the last point that you can see on that region, and also along the line that you create? So you can see this is the last point, right? So this one is the last person, the last point that you can have, which passing through the which are lying on the region, the shaded area region. So that line belongs to which function? So you can see this line is part of the line of, so this point is part of the line of g2. So now you can say that for y, the limit of y is from g1 to g2. Okay. So let's say you can create the vertical line at any point on the any area on that region. So you can also draw the vertical line over here, or also over here. Okay, now I repeat. So now by using this vertical line, so now you move along. You are walking, and then you want to pass through this region. So you move along forward where y increasing. So what is the first point that you can see? So the first point that you can see is this point, right? And this one belongs to g1. Okay, the lower bound, the smallest value of y along this line. And then you keep walking along this line on the region. And what is the maximum y? What is the last value of y, or the maximum y that you can see? This one, right? And that point belongs to the line of g2. And similarly, using this line, okay, we also have the same case, right? Where your first point, okay, your minimum value of y. So we are talking about the movement along the y-axis. So this is the smallest y, where it also belongs to g1, and then keep increasing, and then the highest value of y is here, also part of g2. So you can see that all over the region. So let's say I sketch very many lines on the region. Okay, so all the lower bound, they are the same. All the lower bound. So you have this point, and this point, and all these points belongs to g1. And the highest value of y for this specific line, also you have this maximum value. So also you have always g2. Okay, so now meaning that as a whole, we have the limit. Okay, we have the limit of x is a constant, y is a function. Okay, so that is why we have this. Okay, so remember, firstly, decide the order of integration. After that, based on your region that you have sketched, you have to create the vertical line. And then after you obtain the vertical line, so you can determine the limit of x, where x is constant, and then you can determine the limit of y is function. Okay, So okay, so imagine if you just put, okay, let's say now we are talking about y, because I got a lot of question before this. Okay, why we don't put y just point, why we should put the g1 g2, because we know that on that specific line we should get a value. Okay, imagine if you put the let's say you put the limit for this specific value over here, which is, let's say that one is 4 and this one is 1. So now when you combine them all together for the double integral, so we just replace this one to be okay, so this one just now 1 and 4, right? 1 4. Okay, AB also a number, so you can see that they are all constant. So if you sketch them again, if you sketch this, so you will get the rectangle. Okay, because you see just now the value of 1 4 is actually only along this line, but in a reality the line here, you can sketch the line, the vertical line, all over the region, not only on this specific area. Okay, this is just to the line here is not part of the curve. It's just the line that help you to determine the lower bound of y and the upper bound of y. Okay, and that is when x constant. So now we look at what happens if you have y constant. Okay, so let's say we have another region. So I just look at this region. So your region is this one. Okay, so now let's say you do not know yet the limit. Okay, but then what the thing that you only know is the double integral and the integrand itself and order, because you have decided that y constant, so you have to put y at the back, so you have to start with the x first. Okay, now for y constant now, okay, just now x constant, you have a vertical. Okay, remember, x constant you must have vertical, y constant you must have horizontal. Okay, so now you sketch the horizontal line on the region. This is just to help you, just to guide you to determine the limit of x, because we know that x is function. Okay, now based on this region, so just focus on this line. Okay, now this line is lying between what is the smallest value of y and what is the highest value of y, and you have to think that y is a constant, y equal to 1, y equal to 0, y equal to -1. You cannot have your y equal to any function. Okay, y should be a constant now. Okay, now we look at from this, let's say this is your region. So the smallest value of y is lying along this line. You have a straight line, so all the time for all x, the value of y is the same, right? The value of y never change. So that's why we can see that the lower bound of y, where y is constant, is c. Okay, so now you see that the lower bound of y is c, and then the highest value of y is lying on this line, and this line is belongs to y equal to d. Okay, you have to read just like y equal to c, y equal to d, just a function, but a constant. Okay, will give you a straight line. Okay, so that is about y. Okay, now we want to determine the limit of x, and x should be function. So now look at again this horizontal line. Okay, so now we are talking about, we are focusing on the value of x. So how can you determine that? Again, I'm using these small people. Okay, these small people, and assuming that you are walking along the x, where your direction is this way. Okay, you are walking along the x-axis in this direction, where from the smaller value of x to the larger value of x. Okay, you cannot, in this case, you cannot say that I'm walking from the upper value to the smaller value. No, we have to follow the rule for the limit in our integration, you have to start with the lower value of x to the upper value of x, or the smaller value of y to the upper value of y. Okay, so now again using this line. So that is your line that will guide you to determine the x. Okay, so you can see here, what is the first point that you can see while you walking along the region? So you can see this point, right? And that point is belongs to h1. X equal to h1, this line. So this line belongs to the curve of h1. So now you put the lower bound of x is h1, and then you just walk along to the right by increasing the value of x, right? And what is the last point that you can see on that region when you are walking along this line? So this is the last point that you can see, or the highest value of x that you can have. So that point is belongs to, okay, now you have the line. So you have this line. Okay, so that line is belongs to x equal to h2. So you put the h2 here. Okay, so now again, it's not only, you can actually the line is not only exactly on this area, so you can put any lines anywhere as long as along the region. Okay, so you can see that if you choose this line, okay, now what is the lower bound of x? So the lower bound means that what is the smallest value of x, the smallest point. So that is the point. So that still belongs to h1. Okay, and similarly, if you use this line, what is the smallest x that you can have along that line? You have this, and this one, you have this. And imagine that you have a very many, what color? Pink. Yeah, pink. Okay, let's say you have a very many lines on the region. So they are all starting at the similar point. This one, they are all over the curve, which is belongs to h1. And then similarly for the highest value of x, okay, the terminal point. So the terminal point is here, over here, and they are all over the curve of h2. So that's why now we can say that the limit of y is constant c to d. Okay, you can see that, right? So c to d, and then the limit of x is h1 to h2. Okay, so the same process, the same technique, which means that now y function. So you decide, you said, okay, you ask yourself, when you have the situation where you are given the integrand and they ask you to evaluate the given function without give you the order and the limit. You have to find yourself. So first you have to sketch the region, and based on the region and also based on the integrand given, then you have to decide what kind of order of integration that you want to have. Okay, so let's say you say that, okay, based on the function given, I can see that it's more easier for me to integrate first with respect to x. So which means that y constant. So then you have this order, right? You have decided to have dx dy. Then after that, using the region that you have sketched, and you have decided this, so y constant, you have the horizontal line, and based on the horizontal line, you can get the limit of x and the limit of y. Then you have a complete double integral, and from there you have to evaluate. So the objective of this lesson, double integral, is not only to test you whether you know how to integrate this integration process. So we also will test you how can you determine the order, and also how can you determine the limit based on the function given, and also the information given. Okay, so next I will show you some examples. So just I want to ask you that you have to mentally prepared for this. Okay, I'm not saying that this one is very tough. Okay, but according to my previous student, they said that they always get the review, the comment from their seniors. They say that this subject is very tough. Okay, especially you have to do the multiple integral and so on. But after they went through my class, they said that it's not so hard as they, I mean, as their senior said. So just depend on you. Okay, so just to remind you, this is quite tough if you can't follow from the beginning. But I'm sure that you feel you get fun if you understand the process, the story from the beginning.